Section 2.5 is going to talk about linear functions, and again we're going to look at average rate of change. Now we just looked at linear functions or a linear rate of increase in the last section. Let's reflect on that for just a minute, and that was this one right here. Remember what we said about this one? We had a skier that was racing and they were going downhill at the rate that kind of looked like this. And what do we figure out about this? That the rate of increase of the distance for that skier was steady, right? It was fixed. It's a constant. And that's the kind of behavior that you expect from a linear function, is that a linear function is one in which you have a constant rate of increase. Now the question is whether some of these other things have a constant rate of increase. So let's take a look at graphs of each of these. So this one, yeah, well, we don't exactly have a rate of increase. I'd say it's more of a rate of decrease. But is that rate of decrease constant? That is, if I looked at a couple points here and then another point down below, is that going to give me the same slope of the line? Zach, what do you think? Is the rate of decrease constant?
Yes.
Yeah. Yeah, it's just a nice straight line. So it's rate of decrease. In other words, this ratio here is going to stay constant throughout the interval, as it will with, in fact, you know, I might be able to get away with this. Let's see, let's try 4 minus 7x. 4 minus 7x. It might not fit on our graph too well. Yeah, it's not working too well on this one. But in any case, it is a nice decreasing function, but it's decreasing in a linear way. So this one is linear. Let's take a look at the next one. And let's see, that's back over here. So I'll shut this one off. Is that a linear function? Is its rate of change constant? No, it's going to definitely vary a lot. So this one is nonlinear. Nonlinear. And finally with the last one, let's take a look at that one. Does that one look like a linear function? Is its rate of increase nice and constant? Yeah. Yeah, it is. As you move from left to right, the ratio or the average rate of change is going to be the same. So this one is linear. Now these linear functions share a common feature, and that is you can rewrite them in a nice basic form. So in general, linear function is going to look like this. F of x equals something that multiplies your x plus a constant. Now you probably remember what some of these things are. So let's refresh ourselves in terms of our memory. What's the m here? That's your slope. What's the b here? Y-intercept. And it's nice if you can put something in this form, it's going to be a linear function. But keep in mind that at its heart, a linear function is something that has that constant rate of increase. That as you look at the graph, that those triangles that I was sketching in here for us are going to be increasing in a constant way. So, wrong one. This one. In fact, let's put in a different function. We'll do x plus 1 over 3. Over 3, which is the last of ours. And it's kind of a little bit tight there, a little squished. Let me see if I can't help out a little bit. But there you go. There's your constant rate of increase. And that constant rate of increase is this number here, 1/3. That 1/3, it's not quite visible in this graph the way it's written, or this function the way it's written, but you can rewrite that. Let's write it as x plus 3, or x over 3 plus 1 over 3, or better yet, 1/3 x plus 1/3. And now you can see that that coefficient, 1/3, that reflects your average rate of change. Okay, let's do a few more. Something like you might see on WebAssign would be to ask you to graph something. You can do that by filling out a table of values. Now, depending on the function, depending on how many things I've got to evaluate, at some point I just get bored. I'm like, all right, I'm not putting in all those things and doing it by hand. So let me remind you that your graphing calculator can help. So I'm going to put in the function 8 minus 6x into my graphing calculator. So let's clear out the key history so that you can kind of follow along. Start by hitting y equals 8 minus 6x. And we should be able to come up with enough points to graph this. Double check that your table settings are correct. Doesn't matter what table start is or delta table. So when you hit second and then window, make sure that you're set at independent with ask and dependent set to auto. Assuming those are okay, hit the second key, then the table key to get a graph, or to get to the table, I should say. Let's plug in some values here. Now, if I'm plugging this in for myself, or if I'm graphing this for myself, I'm going to probably plot some values of x near y equals 0 or x equals 0. So maybe something like this, -2, -1, 0, 1, and 2. So just give myself some easy values to look at. When you're plugging in -2, etc., make sure you use the opposite key on the bottom of the calculator, not the subtraction key, to enter in negative numbers. All right, so I've got some nice points here. -2 and 20, -1 and 14, 0 and 8, 1 and 2, and 2 and -4. All right, so we can connect the dots with these. Let's graph them. So -2 and 20, that's going to be all the way up here. And then I have -1 and 14. So it's going to be this one here. Then 0 and 8, 1 and 2, and 2 and -4. Is there a pattern to all these? Yeah, it kind of looks that way. In fact, there is. They all lie on the same nice straight line. What's the y-intercept of this graph?
8.
8. Yeah. And you can see that if you rearrange our function f of x equals 8 minus 6x, you can rearrange it as -6x plus 8. That's probably how I would do this. And you can see that that point right here, 0, 8, that's this one right there. There's your y-intercept. And you've got a slope of 6, -6, I should say. As you move over to the right by 1, you go down by 6. Nice. Now, let's pay attention to the slope here. As you move from left to right, we are decreasing. That's reflective here with that negative. Try and use some of that and think about, without graphing it, which one of these graphs has to be the graph associated with this one. R of t equals -1/3 t plus 2. Now let me rewrite it like this, -1/3 t plus 2, like that. Maybe a little bit easier to write. And what I want you to do, I'm going to call on a couple of you guys in just a second, is don't tell me which one's the right one. Tell me which one we can eliminate and why. So, Omar, I think I see your hand first, and then Jeff next. Pick one of these. Tell me why I can eliminate it. So, first, second, or third.
The one that we could eliminate is the first one.
All right, good. How come I can eliminate the first one?
Because our y-intercept is 2.
Ah, there we go. This has a negative y-intercept, So that can't be right. We've got a positive y-intercept. So nice. So this has a negative y-intercept. This can't be it. Has a negative y-intercept. Nice. Thank you so much. Jeff, I think I saw you trying to volunteer as well. Good. Why can we live with the second one?
It has a positive slope.
Yeah, this one has a positive slope, so that one can't be it. Has a positive slope. Slope. And we need a negative slope. Great. So if you were taking like an SAT test where you knew that there was exactly one right answer and you want to get through this as fast as you can, as soon as you eliminated these two, you know this one's correct and you move on. But for sake of completeness here, let's just check that this matches all we expect here. So Elijah, what does the slope of that line look like it is? Positive or negative?
Negative.
Yeah. Yeah, it's a decreasing slope. So we got a negative slope there. So that looks good. And that matches this negative slope here. And then finally we've got a positive y-intercept, which matches this one here. So this one, yay, that's our winner. That one matches. Nice. Nice. Comments or thoughts on example C here? All right. So in example D, I can't remember if I filled this one in for you or if it was you were asked to fill this one in. I think this one you were asked to fill it in. No, it was filled in. So they're giving this to you, and they're asking you to come up with the equation of a line in the form of y equals mx plus b. So there's two things that we need to determine. What are those two things? What's that?
Y-intercept.
Y-intercept, good. So we need to determine the y-intercept. Great. What else do I need to determine to get that line there? I need to determine the slope. All right, of these two, the y-intercept is easier to determine. Olivia,
Yeah.
can you tell me what the y-intercept is going to be for this graph?
Positive.
Yeah, positive 1. Take a look. It's right here. When x is 0, that means you're on the y-axis. There you go. X is 0, y is 1, so that's telling us that b equals 1. Great. How are we going to find the slope of the line, though? How are we going to find the slope? Yeah. It's just that the slope is what it was before. M is going to be y2 minus y1 over x2 minus x1. Let's see, we've got 5, choose 2. I think there's 10 different ways you could choose a pair of points to figure out the slope here of this line. I'm not sure one looks much easier than the other ones. So, first two? All right, let's go with the first two. So it's going to be, this is your y2, this is your y1, here's your x2, and here's your x1. So filling these things in carefully, I'll have to fix that later. Filling these things in carefully, it's going to be 1 minus 7 over 0 minus negative 3. You got to be a little bit careful here. How's that going to simplify? Nice, thank you. Negative 6 over 3, which simplifies to a negative 2. Does it make sense that we got a negative 2 here? So, yeah. Riley shaking her head, yes. Why does it make sense we got a negative 2 there?
Because it's going in a negative direction.
Yeah. We have a decreasing line, so we expected something with a negative slope. So thank you so much. So your final answer is y equals negative 2x plus 1. Yay. Not so bad. I'm just curious here. If I were to put the question like this on a test, is that going to be an easy one? Like, yeah, go ahead, it's a couple easy points, or is that going to be hard? Hard? Easy? All right, good deal. Good to hear. Thank you. Let's actually interpret a little bit about some of our linear functions. So I actually had a job interview in Bisbee, Arizona one time, and they produce a lot of ore down there, a lot of copper ore. But unfortunately, they use a lot of arsenic to do that. And I just felt a little uncomfortable about moving there. But nice little town. In any case, let's take a look at the amount of copper ore produced from a mine in Arizona. It's modeled by the function 100 plus 31x. Now, I don't know about you, but for me, it's always y equals mx plus b. I don't really like it, and this was taken from WebAssign when they rearrange it like this. I like 31x plus 100. So x is the number of years since 2005, and let's see, what is f of x is measured in thousands of tons. So that's how many tons you're producing. So let's see, what is the slope of the graph?
Positive.
Say again?
Positive.
Positive what? Yeah, positive 31. At what rate is the amount of ore produced changing? Well, what's the rate of increase in this line? So the rate is still going to be the same thing as it was with our previous look at these kinds of functions, the previous look at any functions. The rate is going to be the slope. It's just going to be the slope of your line. That's the rate of increase. So in this case, what is that rate? What's the... Yeah, 31. And let's just change this up a little bit. How much ore is going to be produced in the year 2025? How would I figure that out? Dylan, any suggestions? Some help? Someone want to help out? How would I figure out how much ore is going to be produced in the year 2025?
When you take 2025, that's 20 years later, so you're actually 20.
There you go. So 2025 is exactly 20 years after 2005. So we're going to figure out f of 20. And f of 20, that's going to be 31 times 20 plus 100. I think this is going to be what, 720?
Yeah.
Thank you. So 720 tons. Nice. There you go. Okay. Going downhill on a mountain bike is really fun. It's a lot of fun. And Mylin and Brianna are avid mountain bikers. On a spring day, they go straight down some steep grades. So you've got the elevation here, and you've got the distance traveled here. Which one of these, Mylin or Brianna, appears to be on a steeper ride? Brianna seems steeper? Okay. It could be a little subjective, tough to tell. But we can be more objective about it if we find the slope of these lines. So for Mylin, let's see. Well, we need some coordinates here. They're not really exactly explicitly given to you, but I think you can kind of see them. There's this one here. What's the coordinates of that point? There we go, 0 and 900. How about this one down here? let me zoom in a little bit here for us. It's a little bit past 14,000, right? So, yeah, it looks like 15,000. So this would be 15,000. Oops, I need another 0 there. 15,000 and 0. If it was 1,500, then that would definitely be a very steep slope. So in terms of finding the slope of a line, it's always going to be y2 minus y1 over x2 minus x1. No, it doesn't really matter what you call x1, y1, x2, y2. You just have to be consistent. So which one do you want to call x1, y1? Doesn't matter to me. This one or this one? One on the right. So that's my x1, y1. And this is going to be my x2, y2. Thank you so much. So 900 minus 0 over 0 minus 15,000. Now what happens all too often is that people lose the negative sign here. You end up with negative 900 over, or excuse me, 900 over negative 15,000. So you can simplify that a little bit. So we can cancel out these zeros. You end up with 9 over negative 150, and that's going to be negative 0.06. So a 6% grade is pretty steep. You'd be pretty unhappy if you had to climb up a hill with a 6% grade. In fact, in Colorado and other places where you got a lot of mountains, you'll see signs warning you that at a steep hill ahead it has like a 6% grade or 7% grade. Even a 4 or 5% grade can be a big deal if you're pulling a truck or something like that. How about Brianna? Let's figure out Brianna. 2 N's, thank you. I need some points for Brianna as well. This time we're going to use 10,000 and 0. And how about over here? What do we got there?
0, 400.
Yeah, 0 and 400. So I'll give you a chance to fill that in before I do. If you're watching this later, maybe you can fill it in yourself. Just to be different, I'm going to call this my x1, y1, and this will be my x2, y2. If I proceed that way, then it's going to be 0 minus 400 over 10,000 minus 0. So negative 400 over 10,000 is negative 0.04. So a 4% grade as opposed to a 6% grade. All right. Last but not least, in 2022, I happened to go to a unique spot on Earth, Mauna Loa in Hawaii. So my goal that I finished on this trip was to take my kids to all 50 states. So, yay, cool. Now there's kind of a unique thing that happens. We took a little tour up Mauna Loa from basically sea level to the top. And as we increased in altitude, what happens when you go up in altitude? You decrease in temperature. Yeah. So, wow. Now, I took a few measurements along the way because every now and then you'd see these signs saying you're at 500 feet, 1,000 feet, 2,000 feet, etc. And I came up with these points and I fit a line to them. And this is the equation of the line that I got. Now, it's not going to work this accurately, but what this is saying is what happens to the temperature as you increase your altitude. So what is it saying? What is the negative implying for us as we increase in altitude? Decrease in temperature. Now, the y-intercept you can interpret as, well, that's what the temperature was when we started, right? At sea level, at 0. And then each foot you went up, you decreased by 3,000, 0.003767 degrees. Now, it's not generally rendered that way, but I mean, that's one way to interpret this. You increase your altitude by 1 foot, you decrease the temperature by that much. I don't think it's that accurate, but to make this a little bit easier to understand, if I was to think about increasing it by 1,000 feet, if I multiply this by 1,000, then I move that decimal over here. So every 1,000 feet, you're going to drop about 3.76 degrees in temperature. Okay, that's consistent with what I've seen and what I've heard from my friends in geography, is that you lose about 3 degrees per 1,000. So when you're going up to Everest, which is at 29,000 feet, in fact, I had some friends that just came back from Everest Base Camp. They said it was in the single digits there every night. Not too fun. But you're going to lose about 3 degrees per 1,000. So, okay. All right, that's it here. I just wanted to give you a little spin on interpreting some data. Comments or questions on this? All right, let's give this one a rest.